So we're going to go through independent and dependent events. We have our little formula. Independent events. The idea of independent events are two events that are mutually exclusive. One does not affect the other. The probability of one happening, which means, fix that. Sorry. Which means that your probability of A and B both happening is simply just the probability of event A happening multiplied by the probability of B happening. It makes sense because they're exclusive. Dependent events are one event, in this case event A, needs to happen in order for event B to occur. Okay? So with dependent events, your probability of A and B happening are probability of event A times the probability of event B such that A has occurred. Okay, and which meaning is A weighs in on event B. It changes its original probability had it maybe happened first. So they give you this probability of event B such that A happens is probability of A and B, which is probability of A times probability of B, divided by event A. Well, really, this formula, because we can replace A and B with probability of A times probability of B divided by probability of A. Well, these events, they cancel each other. Those multiplications cancel each other out. That's the probability of B. Yes, but we just got to take into account that how A affects B. Okay. Now, I don't think this question actually strictly occurs with that. No, this one's a little different. This is just odds. Okay, so odds of passing an event. So we've given some information. Odds of passing math, his math exam, are 17 and 3. So this is odds in passing, odds in failing. So in other words, what he's saying is out of a total of 20 attempts, he assumes he'll pass 17 times, fail 3 times. Odds against passing bio. Against passing means fail first, pass second. So out of 10 attempts, he figures he failed 3 times and passed 7 times. What are the odds of passing both events? Okay, well, we know the probability of event A. Probability of A, it looks like we have a 17 in 20 chance of passing event A. Okay. Now event B, what they've given us here is event B is actually odds of failing. So we're looking for the opposite of that, which is like I think they represent it as a prime in your book. That not happening. The opposite event, they usually represent it as a prime. So, in other words, not odds against, but the odds of passing. Well, the odds of passing are 7 out of 10. So we have a 7 out of 10 chance of passing this. So we're going to multiply these two values together. It looks like we have a 200, or out of 200.
119.
What is it?
119.
119? So 119 in 200 chance of passing, which is approximately 35.5. So, sorry, that's not the case, not 35. That doesn't make sense, right? It doesn't make sense that it's 35 because half of this would be 100, and this number is larger than 100. So we divide it again, we must do a little error, and it's 59.5%. So 59.5% chance of passing both of your exams. Does that make sense?
Yeah.